Now we've got a question here. We've got a point on a road being surveyed, and in 1 hour they're saying that 180 vehicles passed that point on the road. And then we want the answer to these 4 questions. So in a 30-second period within that 1 hour, that there's exactly 3 vehicles passed by the point, at least 2 vehicles passed by the point, no vehicles passed by that point, or less than 2 vehicles passed by. So where do we start with that? Now, first of all, what we need a probability distribution. So which distribution can we pick? Well, we need something that's going to be exact numbers. So we're going to need what's called a discrete distribution. So that will give us exact values. So for example, it'll give us a number of 1, 2 or 3 or 4 for the number of vehicles passing by. You can't have 1.5 or 1 3/4. It's always going to be a whole number. So a discrete distribution. And we also want something that's going to give us a value to a particular point at a particular time. So the one that we could use is the Poisson distribution. So Poisson. And then with all distributions, there's a parameter, i.e. a flow rate. So for this one, the parameter is mu. So Greek letter mu. Okay, now the formula for this distribution is e to the negative mu, and then multiply that by mu to the power of n. So that's the number of instances that we're interested in. And then we divide that by n factorial. That's our Poisson distribution formula. That's our PDF. So PDF. So that's the all important formula that we need. Okay. Now we need to find out what this mu is. Or n is just the number of occurrences. So n is the value that we're interested in. So, okay. So 180 vehicles in 1 hour. But these questions here are asking us about 30-second period. So 30 seconds, obviously half a minute. So we've got half a minute. So that's our time interval. And we've got the flow rate of 180 vehicles in an hour, which is 3 per minute. So there our flow rate. So therefore our mu will equal 3 times 1/2, which is 3/2. So that's our flow rate. That's our parameter. So we can give these questions a number. Number 1, number 2, number 3, and number 4. So question 1, let's have a look at that first. Exactly 3 vehicles pass by. So what we're looking for now is the probability that x equals 3. So exactly 3. So for that, we can use our PDF with our values plugged in. So we've got our flow rate is 3/2. Now for exactly 3 vehicles, we know our n is 3. So now we've got e to the negative 3/2. That's our flow rate. And again, 3/2 multiplied by n. So that's to the power of 3. And then divide that by n factorial. So that's 3 factorial. Okay, let's plug this into the calculator and see what we get. So we got e to the minus 3/2 brackets 3/2 cubed divided by 6. So that's going to give us an an approximate value. So with decimal places, that is going to give us 0.1255. So the probability of 3 vehicles passing by is approximately 0.125. So the probability of 3 vehicles, it not being 3 vehicles that pass by in that time, is obviously 1 minus that. So that's our first solution. Next thing we want to know is, what's the probability at least 3 vehicles pass by? So let's work out that one next. So let's rub this off the board and then go to question 2. Okay, so the second question says at least 2 vehicles pass by. So question 2, we're looking for now the probability that x is greater than or equal, because it's at least, is equal to 2. Now the first one, where exactly 3 vehicles pass by, that would also be included in this. So what we could require for this would be something like probability x equals 2 plus probability x equals 3, all the way up to infinity. Now that's a calculation that's going to get very tedious. So that's not going to work for us. We need a shorter route to get that. So what we can use is the value of what is less than 2. So what now we could do is 1 minus, and then open bracket, probability x equals 0 plus probability x equals 1. So if we add those two together and subtract it from 1, that'll give us the probability that at least 2 vehicles pass by, because it's the opposite of what this one is. So if we work out the probability that x equals 0 and x equals 1, add them together, subtract from 1, that'll give us our answer. So let's go straight for that. So probability x equals 0. So use our PDF, e to the minus lambda, which is 3 over 2, and then 3 over 2 times our n. So our number of instances this term is 0. And then divide that by 0 factorial. So now these are just going to be 1. So now we've got e to the minus 3 over 2. Type this into our calculator. E to the minus 3 over 2. That's going to give us approximately 0.2231, 4 decimal places. And then we need probably x equals 1. That's e to the minus 3 over 2 times 3 over 2 to the power of 1 divided by 1 factorial. And again, let's type that one in here. So e to the minus 3 over 2 times 3 over 2 to the power of 1. And then leave that as it is, divided by 1 is the same. That's approximately 0.3347. Okay, so now these two are going to sum to whatever these two sum to. So that's going to give us 0.5578. Okay, so now we're ready to give us our calculation here now. So we can take these off the board now. So I'm just going to write these up on the side. Probability x equals 0, 0.2231, and probability x equals 1, 0.3347. Okay. So then that's going to give us our answer of 1 minus 0.5578. And so that's going to be 0.4422. And again, this is going to be approximated because these are approximate values. So question 2, 0.4422. Okay, let's take this one off the board. Okay, now question 3, no vehicles pass by. Well, we worked that out in the previous question. So 0.2231, so that's easily solved. So that's approximately 0.2231. So it's almost twice as likely for 2 vehicles or more to pass by than no vehicles to pass by. Okay, so now we've got less than 2 vehicles pass by. Well, again, that's going to be x equals 0, probability x equals 1. So there's a probability that x is less than 2. So now what we can do is just add up these two here. So probability x equals 0 plus probability x equals 1. So this is going to be approximately 0.5578. So we can write that up here. So that's approximately 0.5578. Okay.